each section.
Yeah, I mean, that's the idea. I'm not sure how accurate that's going to be, but it's my goal. Radical functions and their graphs. Domain of radical function, we'll kind of look at that kind of quickly. Simplifying radicals, and then radical functions and radicals and exponents. So Monday will be your first homework due in this new stuff. It'll be on the MIPA math evaluating roots, domains, and graphs. And then also the in-class simplifying radicals homework we do on Monday. And then next Wednesday, you'll have MIPA math on exponent review. And then next Friday, MIPA math on rational exponents. So that's kind of what's coming down the pipe. But what we're going to work on to start with is going to be this radical functions and their graphs. So we're going to go through this one together. So make sure you show all your work as we kind of go through this. So we're going to be looking at two types of functions. The square root and the cube root. Here are their graphs. I'm going to make this a little bit smaller. Okay, so we're looking at these two functions. The square root function, which is this square root symbol, right? Square root of x, which all of you are familiar. You've all seen the square root before. We're also going to deal with something called the cube root. So the cube root is this one here. It looks like that. Let me try that again. Little 3. 3. There, that's it. You know what? I'll make this smaller. Little 3 here. That's good. And then the square root symbol. Or cube root symbol. So these are what we call radicals. This little thing that goes down and then up like a little weird check mark and then goes over, that's called a radical symbol. The regular plain radical symbol, this really has an invisible 2 inside of it. There's really invisible 2 inside of there. Square root. And this one has a 3 in front. So it's sort of like, you know how when we have x to the 1 power, we usually just write x, we don't write x to the 1. It's the same sort of thing. If it's square root, there's an invisible 2 in there, we just don't bother with the 2. Because the most basic case is what times itself, you know, we'll talk about those later actually. I don't want to get into the definition of those yet. But yeah, that's what those are. Those are called radicals, which is what we're doing all of chapter 4. So they're also called roots. Square root, cube root. Okay, so this sheet is going to be your Bible for graphing these. So make sure you keep track of this paper. Maybe put a little star in the corner so you can find it easily or dog ear it. Because how we're going to graph these is we're going to plot out these 4 points for the square root. And that's always how we're going to find it. And these 5 points for the cube root. That's always how we're going to find that one. So I'll walk you through these points. So they all center around the origin. So no matter what, we're centered or starting or centered at the origin. So this one starts at the origin. From the origin, so the origin 0, 0, right? From the origin, I'm going to go right 1 and up 1. Why is that? Because the square root of 1 is what? 1. Everybody with me on this part? Let's start with the first one. What's the square root of 0? 0. What's the square root of 1? 1. What's the square root of 4? Everybody think about it. What's the square root of 4? 2. Then everybody write down the square root of 9, and I will ask someone randomly to tell me what the square root of 9 is. David, what's the square root of 9?
3.
3.
Oh.
Good? Everybody with this? With this so far?
No, how did you do that?
Square root of 9.
Yeah.
Yeah. Okay.
Yeah, but I mean, it's been so long since I thought about
Right.
it. So how did you calculate it? Just real quickly.
Because what number multiplied by itself gives me 4?
Oh, okay.
What number multiplied by itself gives me 9?
Okay, so 3 times 3 is 9.
Mhm.
Okay, thank you.
Yeah. So, great. So as we graph these, they graph to 0, 0, and then 1, 1. So I go right 1 and up 1. And then 4, 2, over 4, up 2. Right? So from my origin, wherever my origin is, I'm going to go right 4, up 2. The last one will be from the origin again, over 9, up 3. Right? Because the square root of 9 is 3. So as we shift these, which we will be doing very, very soon, they will go just in that same order. If I move all of this, say I moved it all, my origin, if I move my origin over 1, up 3 to here, everybody with me? If I were to do that, they would all match. So from this, my new center, I would do the same thing. I would go over 1, up 1 for the first point, over 4, up 2 for the next point, over 9, up 3 for the last point, if I were to shift this.
And that's the vertical shift?
That's a horizontal shift right,
Oh.
vertical shift 3 up. Yeah, so it's both.
Oh.
It's a wherever I shift that point. So what I want you to understand is it's these 4 points all kind of, they stay in that same shape with each other, no matter where I go. Everyone's sort of following? So sort of like, think of it like this. How do we get from here to the administration building or the library? Somebody know you need the library. So I would go down the stairs, and then I'd go right, and then slightly left to get to the library. Has anyone ever been to the library on campus? Okay. Okay, let's do it a different way. How would I get from my chair here to that door? I'd go 3 steps this way, 12 steps that way, and then 8 steps that way. No matter what, if I took this room and spun it, moved it over there, or spun it around this direction, or wherever I did with this room, me getting to that door is still going to be the same thing. I'm going to go 5 steps this way, 12 steps that way, 8 steps that way, no matter what I did. Right? I'm still going to go this here, and then 12 steps that way, and then 8 steps that way to get to the door. No matter where I take this and move this room around. If I were to take the building and just move it somewhere else. So what we're saying is, no matter where we take this and shift it, it's always going to be these 4 points will still have the relationship to each other. From here, right 1, up 1. Again from here, right 4, up 2. And again, starting from where the origin, right 9, up 3. They're always going to have that relationship to each other. So if I ask you to shift this whole thing, right 3, up 2, what would you do? Or let's make an easier one. Right 2, up 5. Right 2, up 5, what would we do?
Start at each dot and go right
So,
to 5.
So, well, just from the origin, say I didn't have anything else graphed, I'd go right 2, up 5, and then from here, what would be the other, say you didn't have these, what would be the other 3 points? So, right 1, up 1. Everybody see that one? And then what did I say for the other one? Right 4. Right 4 to the square root of 4. 2, so up 2. And then again from the origin, what's the last one? What's the other thing I know the square root of? 9,
Right, nine
so
and three.
right 9, 1, 2, 3, 1, 2, 3, 1, 2, 3, over here, up. Scroll to 9 is up 3. Right 9, up 3. So then that would be the graph of that one. So that's what we're looking at. And that's why these 4 points, these 3, as they respect to the origins, the origin will move, kind of my starting point will move around. Wherever it moves around to, it's still from this guy, right 1, up 1, right 4, up 2, right 9, up 3. Always. So that's going to be this is going to be sort of our Bible for the rest of this, graphing these folks.
So are you saying on any problem, we're gonna refer back to this
Yes.
set on the bottom?
If I ask you to
Conditions?
graph, if I ask you to graph any translation with a square root in it, yes.
Okay, so we're just using those 3 extra points there?
Yep.
Okay.
Now, for the cube root, I've asked you to graph any cube root and translate any cube root, which you're going to be translating cube roots. We're going to learn this one. This one's a little bit different. This one, I call it like a swoosh, right? Because you're starting here and you're swooshing off. This one I call it the S, because it kind of makes an S. Does everyone sort of see the S? So this is our swoosh. Now we're going to look at our S. Cube root. What's the cube root? So cube root means you multiply something by itself 3 times to get that number. So what multiplied by itself, so that's what square root. So square root means you multiply something by itself 2 times to get a number. So, so for the first one, it was, I haven't been both on there at the same time. What do I multiply by itself twice to get 4? 2. What do I multiply by itself twice to get 9? 3. Right, so that's why there's an invisible 2 there. It says what multiply by itself this many times. But since our basic one is 2, because you can't go to 1, because what do you multiply by itself once to get itself? That would be, that's some point. It's just itself. So, but this one over here is, so what do you multiply by itself 3 times to get -8? -2. Right? Nice and tidy. So -2. What do you multiply by itself 3 times to get -1? -1. Nice fox. What do you multiply by itself 3 times to get 0? 0. Perfect. What do you multiply by itself 3 times to get 1? Someone different?
1.
1. Nice, David. What do you multiply by itself 3 times to get 8? Someone new?
2.
2. Perfect. So, again, here's my center at the origin. From here, I'm going to go right 1, up 1. That's my first point. Right 1, up 1. That's my 1, 1. Right 1, up 1. And then my next one is right, again, from the origin, right 8, up 2. From the origin, right 8, up 2.
So even if it says negative, you're still pulling right 8?
No. I'm not doing, I'm doing these 2.
Oh, all right.
I'm doing these 2 first.
Oh, okay, right.
Now I'm going to go back and pick up these guys. So then from the origin, I'm going to go back 1, down 1. Back 1, down 1. And then for the last one, I'm going to go back 8, down 2. Those are my 5 points. And that's sort of how I remember them. Okay, I'm going to pause this now. All right, super important to again, keep track of these because we're going to be translating these all over the place. And these 5 points still stay that same relationship to each other every time, no matter where I put them. Oh, yep. What's the domain of them? What's my domain?
All the X's.
Right. So all the, well, almost.
Except for the repeats.
So, yeah, my domain is all the x's.
Yeah.
So what can my x's be? me give you here's the graph. It starts off here. It goes out here, on and on forever and ever and ever.
0, infinity.
Yes, it starts off at 0. It goes to infinity. Can we equal 0? Does it equal 0?
Yes.
Yes. So somebody else, is that going to be a round bracket or a square bracket?
Square.
Square. How about infinity, positive infinity? Can we ever equal positive infinity, Jenna? Can we ever equal positive infinity?
No.
Nope. So is it going to be a square bracket or rounded bracket?
Round.
Nice. Good. And then how about my range? My range is my y's, my heights. What's the lowest this goes? Right? What's the lowest it goes?
0.
0. Perfect. Shania, what's the highest it goes?
Infinity.
Yep, infinity. So it's going to be, again, 0 to infinity. Good. All right. How about the S?
Negative infinity, positive infinity.
Yep. So the S is always going to be negative infinity, positive infinity, always for both of them. The heights and the domain and the range. The heights and the left-rights. So that's nice thing. This S thing, no matter where it is, no matter how it translates, it's always going to be, that one never changes. It's always going to be all real numbers, all real numbers. All right, so like I said, this page is sort of like your Bible. You're going to be referring back to it several times, this whole unit. And for the final. Okay,
So I have a quick question about
yeah,
that.
please.
So on these square roots, you know, I guess figure it out, you're multiplying itself by 2 times or 3 times, but how about if you're dealing with a larger number? Are you just like sitting there guessing until you find something, or is there an actual system that you can use to deal with a larger number to figure this out?
Right. So, so here's the deal. In this class, we're only going to give you numbers that are multiples of 1, 2, 3, 4, and 5. That's it. So just how do you figure if something is even and even and even? Then you know it's kind of it's going to be one of those 2s or 4s things, right? And 5s, how do you know if something is has a 5 as a root? If I do multiples of 5, what do they all have in common?
They end in 5?
They end in 5, right? And then you just have to sort of sort out the 3s. Those are kind of the other ones, right? So that would be your kind of your best shot with if it's not one of those. If it's not even, does it end in 5, then the root probably has a 3 involved in there, right? If it's not the square root. The square root ones are kind of obvious because the square roots, we can all pull out our calculators and just do square root of 81 and say, okay, what's square root of 81? Oh, it's 9, right? So stuff like that, you know, we can kind of sort out. But really the only, if we talk about third root, fourth root, fifth root, it's just going to be the 1, 2, 3, 4, 5. That's it. Okay. As with any graph, the graphs of square root and cube root functions can be reflected and translated. We're going to do some transformations. So, again, we're going to start off with our basic graph and apply translations to find the function that represents the transformed graph. Okay, so let's talk with the first one. Talk about the first one. Really? Okay. Is that, if I go smaller, is that going to be too small? Is that too small? Yeah, everyone's okay with that?
Yeah.
Okay. All right, great. So we're going to take our basic graph and shift it 1 unit downwards. That means that my origin, kind of my center, goes down 1. Everybody put in your graph where that would be. Start the origin, go down 1. Here's my origin. Can everybody see your lines in your graph? Okay.
0.
Okay. All right, sort of like here.
You always start with 0, 0?
Yes.
Oh.
Or always. Our origin is our base always. Okay, so I think I'm starting right here. Everybody on board with that part?
Yeah.
Now, is this a cube root or a square root?
Square root.
Square root. So that's going to be the one where it goes, it's just the swoosh, right? So I'm going to go right one, up one. From the origin? Yeah, graph it. Graph it. You graphed it already? And then, so right one, up one. So I'm going to start from my new origin, or my new center, I'm going to go right one, up one. From the new center.
4 up 2.
And then from my new center, I'm going to go right 4, up 2, right? And then what's the last one?
Right 9 up 2.
Right, how many?
9.
9. Up how many? Mm-hmm. Up how many? Right 9 up. That's square root of 3, of 9?
3.
Yep. Right 9, 1, 2, 3, 1, 2, 3, 1, 2, 3, up 9, up 3. And then draw your swoosh. Swoosh. Okay, so the new function, where did I shift? Did I go left, right, or up, down? Up, down. So someone else, up, down, is that on my inside or my outside? Outside. Right? So up, down's on my outside. So I'm going to take my function, and it's, I'll call it g of x is equal to, it's on the outside. So I'm going to write my function, square root of x, and then on the outside I'm going to put what? Down 1 means what? David?
Down 1.
Yep, so what would I do to the end? Plus 1 or minus 1?
Minus 1.
Minus 1. Right? It's on the outside. You can never go inside of these things, so leave it alone. You're done. Boom. Good?
And then it's important that you don't extend that top of the little check mark
Exactly.
over the minus, right?
Super important you do not extend this over the, because then it'll be inside.
Yeah.
And all of a sudden it become a left-right shift instead of an up-down shift.
Okay.
So everyone see the difference? That was a great point. So Eric pointed out, if you do not extend this over, because if you extend it over, all of a sudden it becomes inside, and then it's no longer an up-down shift, it's a left-right shift. It's totally different. Great. What's the domain of the new function? Oh, we'll talk about that in a minute, more in a minute, but what's the, where does it start? It's 0. How far does it go? But my domain is my left, right?
Oh,
So what's my domain? What's the furthest left it
0
goes?
to infinity.
Yeah, it goes to infinity. What's the furthest left it goes? This way. What was that?
1.
Almost. So as I trace along here, what's the furthest left or right I go? So I'm going to go back and forth along here. What's the furthest left or right I go? Well, what's the furthest left I go?
0.
0. Right. I don't go past this. I never go past this y-axis. I never go past 0. Remember, domain is about left, right. So it's going to be from 0 to infinity. My height, my y, starts at -1. I don't think your handout includes, it just has the domain, right? Not the range? Oh, it does have the range.
That's right.
Okay, great. So then the range, aha. Now Natalia, what's my range?
-1.
My range starts at -1. It can't equal -1, and where does it end up at, Ryan?
Infinity.
Infinity. Good. Great. Okay, so let's do B. The same graph is shifted, the square root graph is shifted 2 units to the right. So everybody put in where your new origin is. Start at 0, 0, where's the new origin? 2 to the right. There's my first spot. Correct? Now everybody put in the next two spots. You can't do the third spot because it's off the page, but just do the next 2. Graph the next 2 points. What is it? Over 1 up 1. Over 4 up 2.
4 and 1 up 1.
And then make your swoosh. Over 4 from here. 4. Up 2. 4. 1, 2, 3. From the new one. Up 2. And then make your swoosh. Go. Okay, so these ones are going to be from our new center, over 1, up 1, over 4, up 2. So it should be like that, right? And then it would have been way over here somewhere. That would be the other one. So let me draw that line. Like that. Good. What's my new function? Okay, so I'm shifting 2 to the right. Left, right. Shania, is left, right on the inside or the outside? Left, right shifts. Okay, so up, down is on the outside. Right? Up, down is on the outside like we did over here.
Oh, inside.
Left, right is on the inside, right inside where X is. So right inside where X is, we're going to shift right inside where X is. So right inside where X is, we're going to do X what? So right, do we do the opposite?
Right,
So it would be, anyone?
-2.
Minus 2. Right would be minus 2. Because it's right inside where X is.
now, is brackets needed around that or no?
No, you can if you want.
Okay,
But since it's inside, this is sort of an invisible bracket by itself, in a
Okay.
way. Right? Because this really means put a bracket around it, raise it to the 1/2 power. So
okay.
this sort of is sort of its own bracket. Yeah. If there's something inside of here, like a 3x, then you'd do that. But I don't think we're going to give you anything like that.
Oh, like an x exponent, like an x to the third or something?
No,
Oh.
like we're not going to have like
Oh, like a number.
a number in front of the
Oh,
x.
okay.
We're not gonna, yeah. Okay. Or I mean, you're right. You could put this around it, and then there's nothing being multiplied in front, or it's not being raised to a power inside, so you can just take them away.
Hmm.
So yeah. So theoretically, yes, you should have one in there, and then you can remove it. Okay. What's my domain of the new function? What's the furthest left as I go along here? What's the furthest left I go? What's the furthest left I am? It's right here. Where is that?
2.
2. My left, right is 2. What's the furthest right I go? Go ahead. Infinity. Perfect. And then my range. What's the lowest I go? As I go along here, what's the lowest my pen ever drops to? Natalia? Yes? It's the lowest I ever go here. Calista, Callie, you want to help us out?
Sure. Lowest?
Yep.
0.
0. What's the highest I go?
Infinity.
Infinity. So again, we can sort of think of these as sort of being my left, right. What's the furthest left I go? Right, that's sort of my limit as to how far left. Let me clean that up a little bit. Right, this is how far left, right. I can go left, right wise, I can go all this side, but not that side. So it means I can go from 2 to infinity. So that sort of helps people kind of think about it. And then if I'm looking at up, down, if I look at the whole thing up, down, let's see, what's the furthest? You can go from here and up. Right? It never goes below that. Oops, that's not true. I gotta move that up. Oh yeah, that's true. Yep. It can go from there and up. So it means it starts off at 0 and it can go up to infinity. Yep, so you can do a check 1, 2 on a graphing calculator. Not a big problem. So I'm going to have you folks do C and D and E, and E and F. So C, D, E, and F. So C and D, okay, well, I'll do C with you actually first before we go. So this one, 2 units up. 2 units up. So that would be, everyone marking where it's 2 units, you start from the origin. Remember, you always start at the origin and mark in 2 units up. Everybody do that. Upwards 2. Up 2. Start at the origin, go up 2. The origin is where they cross, where the axes cross. Now, this is a cube root. It's not the square root, it's a cube root. So 2 units up, it's a cube root. So that means it's going to be that other, it's going to be the S. What's up with the S? Over 1, up 1. Over 8, up 2. And then check your Bible in the beginning. It also goes back 1, down 1. Back 8, down 2. So this would be my S. Like that. So now what's a new function? So everybody write down what you think the new function is. It's up 2. So up, down is on the inside or the outside?
Outside.
Outside. Write the new function. We'll check it later. What's the domain of the new function? What's the domain of my S? How far left, how far right does it go?
Negative 8.
Oh, dude. It's all real numbers.
Oh, yeah.
It goes on and on forever.
Everybody follows infinity.
What about my range? How far down and up does it go? Again, all real numbers. Right? Both of these are going to be all real numbers. Negative infinity or positive infinity. For both of them, always with the S's. Okay, so you folks fill in what should go there. I feel like you can do that with your groups. So you're going to do C, D, E, and F in your groups, and we'll come back.